Okay, so let's go ahead and work this inclined plane with friction situation. So this is actually the very same situation we did in a previous lecture, but now we have friction in there. So let's go ahead and identify our forces. That's always our first step. And we always have weight, mg, pulling downward. The normal force, and I didn't draw that very well, pointing up perpendicular to the surface, which I didn't do very well. And since this is sliding down the slope, there's a force of kinetic friction pushing up the slope. Okay? So those are our three forces. And remember, when we have these incline type problems, the easiest way to solve them is to pick a tilted coordinate axis. So we're going to pick our y-axis, pointing perpendicular to the surface, and our x-axis points down the slope. Okay? So let's label our forces in there. We have mg pointing down. The normal force points up, and kinetic friction points up the slope. Okay? And a little bit more geometry here. This is a 20-degree angle, and therefore this is also a 20-degree angle. Okay? So it's basically the exact same setup that we did for this inclined plane problem without friction, except now we have this kinetic friction force that comes into play. And if we want to know what the coefficient of kinetic friction is, that's the question. Well, the coefficient of kinetic friction is related to kinetic friction force by this. So the coefficient of kinetic friction is the force of kinetic friction, which we know, we're given in the problem that this is 10 newtons divided by the normal force. So that's what we need to solve this problem. We know what the kinetic force of friction is. We just need to find what the normal force is here. Okay? So that's kind of our goal in this problem, is to find the normal force. Now, what else do we know about this situation? Well, there's acceleration pointing down the slope. There is no y acceleration, remember, because, this box, this sled or whatever, is not going to spontaneously levitate in the y direction. All the motion is up or really just down the slope. So our only acceleration is an x acceleration. So applying Newton's second law to both the x and the y components, so the Newton's second law holds for the x and y component. The sum of the x forces is mass times x acceleration. And then the y forces is mass times y acceleration. But the y acceleration is 0 here. It's all x acceleration. So that's 0. Okay. Now, really, in this problem, we're only interested in finding the normal force. And so if you recall, really, it's the y component that best deals with the normal force. So we really don't need to apply this to this problem. We may come back at the end of the problem. We actually will, and apply this. But let's just consider the y component for now, the y components. So let's figure out the y components of all these three vectors. That's what we want to do first. So the sum of all those y components is 0. So the y component of the normal force, well, it's entirely in the y direction. So the y component is n for that. Now for mg, for the y component, we need to figure out this length right here of this kind of right triangle. And to figure out that, it's adjacent to our 20-degree angle. So you have to use cosine of 20 to get that length. So it'd be mg cosine of 20. And since we're dealing with something below the x-axis, it's going to be negative. So negative mg cosine of 20. And then the force of kinetic friction has no y component because it's entirely along the x direction, the negative x direction. So that doesn't have a y component. And then those have to add up to 0. Okay? So the normal force then is equal to mg cosine 20. And therefore the coefficient of kinetic friction is the force, I'm sorry, it's right here, is the force of kinetic friction. This is 10 newtons, remember, so it's 10 newtons. Okay, that's F of k here, that's 10, remember, divided by the normal force, which is mg cosine of 20. Okay, n is 20 kilograms, g is 9.8. You do 10 divided by 20 divided by 9.8 divided by cosine 20, and that gives you the answer 0.0543. Okay, and remember, these coefficients are unitless. Okay, so there are no units for that answer. So that gives us the answer of the coefficient of kinetic friction. Now, what about the x component? What can we learn from the x component here? The x components, the x equation for Newton's second law. Well, let's find our x components then. The x component of the normal force is 0, because it's entirely along the y direction. So that has no x component. The x component of this guy is this length here. And so it's opposite the 20-degree angle, so that's sine of 20, mg sine of 20. The x component of this guy, well, it's in the negative x direction, so it's minus that. Okay? Which, remember, we're given in the problem, it's 10 newtons. And that has to add up to mass times acceleration. Okay. So what this does is it gives us the x acceleration. Okay, divide both sides by m, and we find that the x acceleration, m divided by mg sine 20 is g sine 20, minus 10 newtons divided by mass. So you plug the numbers in here. G sine 20 is 3.35 meters per second squared. Okay, and so if you recall, that's the answer we got in our original frictionless situation. So that answer was 3.35 without friction. But then we subtract 10 divided by, our mass is 20. So 10 divided by 20 is 0.5 meters per second squared. Okay, so this would be the frictionless situation, but because of friction, your acceleration is a little bit lower, and it's 2.85 meters per second squared. So that's how to find the acceleration.